In this tutorial, we have a compressor, in which gas enters at a temperature of 50 degrees Fahrenheit, a pressure of 1 atmospheric, and a molar flow rate of 100 pound-mole per hour. The molar composition of the feed gas is also available. This compressor, working at an efficiency of 75%, raises the pressure of the gas to 50 pounds per square inch. This compressed gas is further cooled in a cooler with negligible pressure drop to a temperature of 32 degrees Fahrenheit. This cooler gas goes to a flash separator, where it is separated into two streams. First one is vapor stream, and the second one is liquid stream. In this case, we have to determine the mass flow rate and composition of both streams. Now, we will model this whole process flow diagram in Aspen HYSYS. Open Aspen HYSYS software. Click on New button. Click Add to open the component list. Add pure components by typing their names in the search bar and pressing Enter. Enter C2 for ethane, C3 for propane, IC4 for isobutane, and NC4 for N-butane. Select the fluid package option and click Add to include a property package. From the list, scroll down and select Pung-Robinson. Finally, click Simulation to develop the process flow diagram. Add a material stream by dragging the blue arrow from the object palette. Double-click the stream to enter properties and name it Feed. Set the temperature to 50 degrees Fahrenheit, the pressure to 1 atmosphere, and molar flow rate to 100 pound-mole per hour. Next, open the Composition tab and enter the mole fraction as shown in the table. After defining the composition, click OK and close the material stream window. Now, add a compressor to increase the pressure of the feed stream. Double-click the compressor icon to open its window and rename it Compressor. In the Inlet field, select Feed Stream. In the Outlet field, out Comp Gas to create a new material stream. In the Energy field, enter Comp Work to create a new energy stream. Switch to the Parameters tab and set the adiabatic efficiency to 75%. Select Worksheet tab and enter 50 CA as outlet pressure in order to fully define the compressor. Now, the status bar turned green, confirming that the heat exchanger is fully defined and results are available. Now, add a cooler to decrease the temperature of gas to 32 degrees Fahrenheit. Double-click the cooler icon to open its window and rename it Cooler. In the Inlet field, select Comp Gas Stream. In the Outlet field, enter Cool Gas to create a new material stream. In the Energy field, enter Cool Q to create a new energy stream. Switch to the Parameters tab and enter a pressure drop of 0 kPa. Select Worksheet tab and enter 32 degrees Fahrenheit as the outlet temperature in order to fully define the cooler. Now, the status bar turned green, confirming that the heat exchanger is fully defined and results are available. Now, select Flowsheet Modify tab to automatically adjust the process flow diagram. Click Auto Position All and then click Yes. Magically, the PDF is automatically adjusted. Now, add a flash separator. Double-click the icon to open its window and rename it Separator. In the Inlet field, select Cool Gas Stream. In the Vapor Outlet field, enter Top to create a new material stream. In the Liquid Outlet field, enter Bottom to create a new material stream. Now, the status bar turned green, confirming that the separator is fully defined and results are available. Select Worksheet tab. The flow rate of top and bottom streams are calculated. Go to the Composition tab to get the composition of both streams.